Hello and welcome to today's webinar, Hot versus Cold Data, its influence on data placement decisions and what to do about it. Today's event is brought to you by DataCore and produced by Actual Tech Media. My name is David Davis, and I'm excited to be your moderator for today's event. Before we kick it off, we've got a little bit of housekeeping that we first need to cover. I'd like to talk to you first about the purpose of this event, of course, is we want this to be a really educational event when it comes to learning about your data challenges and what to do about them. So we encourage you to use the questions box there in the GoToWebinar control panel, and we'll have a dedicated Q&A session at the end of the event, and we'll pick the best questions for that session. So make sure you get in your questions early, and we'll be covering those questions at the end of the event. We also want to point out that you have a couple of handouts available for download there in the GoToWebinar control panel. There is a white paper that is around the same topic as today's webinar that has more detailed information on some of the technical topics that Augie will be discussing, our presenter. And then there's also the slides deck, or the slide deck from today's presentation. You can download that in the handouts panel on your GoToWebinar control panel as well there. And then after the Q&A session, we'll be handing out one $300 Amazon gift card to one lucky attendee on today's webinar. If you're watching this event on demand, I'm sorry, the drawing has already occurred. You can find the full price terms and conditions at events.actualtechmedia.com. And with that, I'm excited to introduce today's presenter. That is Mr. Augie Gonzalez, Director of Product Marketing at DataCore. Augie, thanks for being on the event today.
Thank you, David. So we have a timely topic because part of the issue we're running into is that we're spending a lot of money on a lot of data, and we need to be a little more frugal about that. And especially because much of that data is pretty chilled out. It isn't doing much for us. One of the ways that we know that firsthand is we've looked at telemetry information from thousands of customers around the globe, and we see patterns developing there. And those patterns are telltale signs of where information is being frequently accessed and where it's not. This little chart here is a trace from some of those telemetry patterns, and it's very representative of what we see in the real world. So it's indicating an I/O distribution. So let me walk you through that. The left axis, the vertical axis, is basically indication of the higher the number, that means the temperature. So some of those top end of it is the temperature range. That is the frequency that we're seeing lots of IOs being generated against certain data. And then as you move to the right and you see that sloping comes off right at about the 20% of the pool, you recognize that there's very little access to that data. So the translation, the first translation that you get from this is that something less than 20% on average of the data sets that are in these pools of these storage farms basically have been used and are relevant in the near term. The second part has to do with aging. So the amber squiggly curve that you see there in the middle, that's an indication of the age. As the numbers progress up, it's how long they've been resident on the system. And the same thing holds true there. What you see is that a very small part of that is actually being accessed, and soon thereafter it drops. The access values drop off dramatically. So even though we're saving space for this data, we're not doing much with it. That's in essence what that is trying to communicate across. And we see this over and over and over again. So that in some circles, this is best described with just classical temperature gauges. You can think of them as hot data being that which is high frequency of use, whereas more moderately accessed information and those records and blocks, we would consider those warm. And as data ages and becomes less and less frequently accessed, at some point it actually reaches kind of this cold or even frozen stage that we attribute some different characteristics to, because it's not nearly as valuable. So usually what we're asked to do as in charge of the infrastructure is keep that eye on the hot data. You know, that's where everybody's focus has been. It's like, this is the stuff that I need to get to quickly. What we have to recognize, though, that there's a huge hidden cost, that kind of that iceberg effect, where there's a lot of it that's either chunk warm data and a lot of it is mostly cold data. And it is chewing up really valuable capacity and real estate on your floor. So we've got to take measures to avoid that extra expense and investment that we're making in not only housing the data, but keeping it current and well protected. To put some numbers on this, think about this information. From, on average, since 2016, organizations that have climbed in capacity roughly 5x. So at one point they were tracking, some of you are probably right in the middle of this cross section, maybe at about a petabyte and a half of data, and you may now be seeing up to close to 10 petabytes of data. So if you consider that kind of growth, and you consider how much of your investments and your budget is being put to use in a lot of that being cold data, wow, we've got a real nightmare in our hands in terms of throwing bad money after it. So we've got some polling questions that David would like to ask at this point.
Absolutely, yeah. So I've just popped up the poll question for everyone out there in the audience. It says, how many different types of storage devices do you use to segregate between hot, warm, and cold data? And so the options here are just one. Maybe you just have a single SAN and you put everything on it. That's great. And then from there, you know, you could have two, you could have three, and you could even have a mix of on-premises tiered storage as well as cloud storage, or maybe some other solution. So I'll give you a moment to answer this question. I see some responses already rolling in. Thank you for those. And then I'll share the results with you so you can see how you stack up with your peers. So let's get just a few more responses. Thank you, everyone who responded so far. And I'm curious to find out the results of this poll.
As am I.
All right, looks like a good majority of the audience has responded. Thank you, everyone. Let me go ahead and share the results of this with you. All right, so it looks like 50% out there say they have two types of storage, one for active and one for archive data, followed by 20% who have a mix of on-premises and cloud storage, and then 18% after that just have a single array, regardless of the temperature. What's your take on this, Augie?
It's quite revealing, I think, in general. It's good to see that a lot of you are attending to business, that 50% of you or more, actually over 80%, are doing a pretty good job of managing this. So we're going to have another polling question later, David, which is, how do you pull this off? And in between, we're going to learn some things about maybe ways to alleviate that burden. So let me get to that next.
Okay.
But before I do that, I want to bring up some interesting research by a company called Nucleus Research. And they looked at this phenomenon almost as a half-life. If you think of how things like radioactive materials like uranium, they're known to have a half-life. That means they still have properties from the outset, and then as they age, they're still dangerous. Okay, in this case, we don't think of it so much as dangerous, but from the point that a piece of data is born, how many hours is it valuable to us? And what they did is their surveys looked at a wide range of organizations, and both in regulatory markets, in commercial, online retail, and everything else. And they found these three waveforms. The first one in blue is the folks who are operating on tactical data. So they're making near real-time decisions based on information in front of them. And they found that the half-life of that data was less than 30 minutes. So after 30 minutes, and in some cases as little as 6 seconds, decisions were made on the data. If anything beyond that, it was useless. They could just throw it in the floor because it didn't have much value. So that's how short the span of life for those types of organizations and transactions. Think of them in terms of somebody doing e-commerce or something like that, where they're trying to decide, can we fulfill this order now? If I wait a little bit longer, or you yourselves, if you are booking airline tickets and you realize how volatile some of this information is, you think you've got a really good deal, you stop to check with your partner, and by the time you get an answer to say, go ahead and buy it, it's like, oh no, it's gone, you know? This is the kinds of things that we're talking about here. The second waveform that you see is described as operational. So this may be where we're making some inventory decisions, or we have a little bit more time to crunch on the data before we reach those conclusions. And so clearly its value is elongated more. In this case, they estimate that between 30 to 70% of the data may still have some residual value, even after maybe 8 hours for predictive analysis and future planning. And then there's the green curve. The green curve is really kind of that big data view of the world that says, for strategic decisions, people who are making, let's say, product development, or in the pharmaceutical space, they're looking at data over long windows of time. That data remains valuable for a prolonged period. On average, the real sweet spot may be in the kind of 56 hours for them across the spectrum that they analyze, but the standard deviation on that can be quite immense. So a long tail on that. So curious way to look at that, I thought, for sure. So what can we do about that? Well, first we got to take a sample of how much actual volume we're dealing with. And here's another representation. It basically says the left chunk, the hot data, which is often the most recent data, that tends to be a near constant. So the amount of hot data we process is relatively the same amount in terms of overall terabytes or petabytes, whatever it might be in the case. But as you go to the right, those numbers accumulate. So warm data builds up a little bit. Cold data really collects over time. And that's just as we continue to pile more archive data, even goes into the frozen bucket. Those things continue to pile, and the hot data that we can actually work on remains a fixed portion of the overall space. So that also will influence how much space you need to devote to this. Now, moving data between tiers, is one of the parts that I think most people would agree is the most difficult part of that. And I like to think of them more in terms of these, so give some personality to these tiers. At one extreme on the left, we have kind of the all-flash array, the fastest beast in the world. And then we have the hybrid arrays, which have a combination of maybe solid-state disk and spinning disk to try to balance the price points. And then we have more capacity tiers and elastic cloud storage. So the part of the difficulty here is when you look at your overall information volume, where do you start? Where do you begin to figure out which parts? So all of you who said, hey, I have 2 of these, one active and one for archive, how are you reaching that decision? And those of you who have even 3 or more types, seems making that choice. And how long does it take you to determine, okay, now it's time to move it from the left to the right because it has in fact aged. And every time you do that, how much disruption are you causing? Are you having to take planned downtime or taking some other unnatural measure in order just to reduce how much data you're keeping on your hot, most expensive storage. That's one of the troubling parts of this. Now, there are clearly, if the world was perfect, maybe one would say, well, why don't I just standardize on one type of storage, maybe a hybrid array that has a little bit of all of these things and save myself from having to move anything. Well, if you look at the price points associated with that kind of gear and try to look at those 5 petabytes, et cetera, it gets really expensive real quick. So if you happen to be a very affluent organization and you can do that, maybe you can get away with it. But most of us who are dealing with tighter budgets cannot operate that way. It's especially true when you look at the price differential between the all-flash kinds of animals and anything in between. And this is a Gartner calculation that they did, and they estimated there was about a 6x difference between the fastest storage devices and those that you would consider as appropriate for colder data. So that's the range that you're having to work with, and you have to evaluate in coming across these decisions. So where data core pops into play here is we look at these variables and we account for them right from the outset. The data core represents a storage virtualization technology that says we don't have to expose what kinds of tiers are sitting in the background, but we can make some intelligent decisions about where to place that data on your behalf, given what we're seeing coming down the pipe from the application servers. And use intelligent machine learning to basically assess, okay, this data is absolutely getting hammered versus this other one that is not, and so we will move the data accordingly, hands-free, without anybody having to inject or take downtime to accomplish this. And those tiers can be as numerous as you like. In some cases, usually we don't see any more than 6 or 7 of these, but you can, if you got really crazy, do up to 15. So that just gives you an illustration. Essentially, what we're saying is that you can put diversity to your advantage, whereas most people would kind of shy away from having these different tiers. We're kind of encouraging you to do it because we know that to the degree that you can offload the task of taking advantage of it, you're saving a lot of money. So the fundamental software piece in the stack that I'll concentrate on today is the automated storage tiering element. And this is the part that basically makes the decision on your behalf on where specific blocks of data should be located based on access frequency as well as user preferences. So there's a couple of dimensions to this. One is kind of the automaton that's going to make choices, and the other one's going to say, well, you know, I might want to override that. One of the things I want to point out is that if you're doing this manually, or whatever tools you're using today to move data from, let's say, your hot tier to your archive, you're probably doing that on a complete volume basis, a complete file basis. Where data core operates is what's known as sub-Lan granularity. So think of this as a database. I might say, well, this database is a financial system of record that needs to always be on the fastest tier. That would be your first assessment of where it needs to be. So if you take this whole virtual disk here, that might be the D drive or the E drive, and that entire thing, you might have put it in an all-flash array given that condition. What this software is doing, what the data core software is saying, let's look a click down from that, because in fact, when you look at that entire database, you're going to find that only a small fraction of it is actually being accessed quite frequently. Those red blocks that we're showing, those are the ones that are getting hammered. There's a bunch of the so shown as here as amber blocks are only being moderately accessed, and then there's ones that are absolutely not being touched. So we will make the decision on what to move at this sub-Lan level. And therefore, we would take that entire, what appears to be a monolithic volume or a database, and actually carve the chunks out and appropriately locate them in tier 1, tier 2, and tier 3, so that we're not taxing the all-flash array with capacity obligations that tend to slow it down. And at the same time, we're reducing the price per terabyte that you're paying for the bulk of your data, which is sitting on, can now sit on tier 2 or tier 3. So that's the essence. It's doing this trade-off on the fly based on what it's actually seeing live, not based on what you might have guessed at. So this is an empirical understanding of the life cycle of the data as we're viewing it in band. To add to that, we're also, the software is not just doing the tiering as you would expect that I'm showing here, but it's also doing caching so that any bursts that are coming through, we can absorb that. So if you do get those spurious spikes, we can absorb and respond to those if they're on read traffic or frequently accessed data. We don't have to go all the way to the disk to do that. We actually do that from memory. And that turns the I/O around very quickly, so the response time is improved and accelerated over what you would see in a classical just tiering system. This is all with the intent of absorbing any of the perturbations that you might see. But it's, at the end of the day, what we're trying to do is ensure that the most active data is placed on faster storage and that the less active data is placed on lower cost storage. That's obviously the recurring theme throughout here. Now, the visuals that you have to appreciate how the system is behaving to this is in this screenshot. It's a heat map, and the heat map basically says, if you look at these horizontal bars here, this is the tier 1. This is how much of it is occupied. Here's how much is occupied in tier 2 out of the entire space that's available, and here's how much in tier 3. So in a 3-tiered configuration, the software has deemed that it needs to keep about 75-80% of tier 1 occupied with hot data. We're finding that about maybe 60% of the capacity in the mid-range space is suitable for warm data, and our overall store for cold data in this example is about maybe 40%, 30%. So you have that visual in front of you to understand the leveling that's occurring. You also have full control of this. So this is, sometimes these automatons can be a little bit disturbing from somebody who's used to having hands-on. So we give you that control. You can establish, first of all, what you consider to be tier 1, tier 2, and tier, et cetera, storage. And you can explicitly assign that. So in this case, I would say the all-flash array in the East production pool, that's my tier 1. My hybrid array that I have, that's kind of the balance of these two extremes, would be my tier 2, and any secondary storage I might label as tier 3. Any time now, so think about leases of storage or when you're doing expansion and refreshing, you bring in new gear. A lot of times that what was your premium number 1 tier storage takes a second fiddle. That is, becomes demoted to a second tier because the new technology is obviously faster and better price performance. So at that point, we can explicitly say, okay, we have a new member, we have a flash drives that we're putting right inside these systems. And so those will be now the new tier 1. I'll relegate the all-flash array to tier 2, all without taking any downtime and without the applications knowing that we're doing this in the background. This reallocation then will shuffle those blocks as it sees opportune to move all the hot data that was in the all-flash array will now move to the flash cards, the NVMe flash cards that you've just inserted into the system as part of your upgrade. Similarly, if you had thrown in some very inexpensive storage and decided that that was going to be your archive tier, then we would define that as maybe tier 4, and we could explicitly call out that we're moving more of those blocks that were in tier 3 to that tier 4. And anytime you can also decommission storage from here as well. And it will basically say, as I pull any resources out, let me make sure I know where to drop that data, where to move it before I put it to sleep. We do have, and I think before we started the webinar, David was asking me some of these questions about how do you override this? And it's super easy, and there's lots of reasons to do that. Sometimes we have end of quarter processing, which even though there was things that throughout the quarter we were deeming as, oh, not so important, all of a sudden at the end of the quarter in financial circles, it becomes important to place certain blocks in the fastest storage area because we know we're going to be doing a lot more analysis, or right after the quarter when we're trying to see how well we did. These, we can then specifically pin volumes to a tier. So we can say, okay, this particular volume has this storage profile, and we have chosen to place it for this period of time in this tier. And then maybe after several days, I can go ahead and give it back to the system, let it reshuffle things around. But for right now, I want to call the shots. This is also done for backup purposes. So if you're doing archives, or you're doing backups, just regular snapshots to backups, and you want to place those in explicit, even though they are seeing frequent activity from your regular backups, you don't want them to be viewed as, hey, this is hot data because I'm seeing quite a few accesses, quite a few IOs to it. Instead, we will explicitly define those to fall into your tier 3 or tier 4, wherever you've chosen best fits that class of storage. So let's understand a little bit about how you're doing this.
Yeah, I'm going to pop up the next poll question now. The question is, what tools do you use to move data to different storage as it cools? So your less active data, what do you do with it? Do you just leave it where it is because you don't have tools that are available? Do you copy the data and then delete the original? Or do you use something like storage vMotion to move that data off, or some other method? And so I'll leave this up for a minute and let everyone respond to that. Augie, I got a question for you that came in. They're asking, you mentioned how this solution is sort of a like intelligent, robotic, smart software storage administrator, making all these decisions for you and moving the data where it really needs to be. As an administrator, how do I know where my data is?
So that's a part of those visuals that I provided.
Yeah. You
can drill down and you can actually look at a virtual disk. You can look at that database and it'll say, okay, this virtual disk is partially split between these 3 tiers in this proportion. So very much the diagram I showed earlier with the volume having the red, amber, and blue, you would basically see those fractions expressed in the console view.
Okay. And then if I want to override that, like you were showing, I can create a policy to effectively pin data in a certain tier or a certain place.
That's right. I could say, okay, fine, you've been doing it that way. Right now, I need you to put all of that in tier 1 for this week. We've got orders from above to go do that. Let's switch it, and the system will go shove it over there, move it out of those tier 2 and tier 3s, and lump it all back into tier 1.
Very nice. Very nice. All right. Looks like most of the audience has voted on this poll. Let me share the results. And it looks like 40% say they use storage migration, such as vMotion. 32% copy the data and then delete the original. 15% have some other solution they're doing, and 13% don't have the option to do this today. How's that compare to what you've seen in the past, Augie?
Yeah, I think that's a fair mix compared to what I've seen in other samples that we've done. It is it still begs the question is in terms of granularity and how involved you have to be in that process. And that's one of the things that I want to draw your eyes to throughout this conversation is the fact that you're having to do this, you're having to take the steps to migrate information to, in some cases, copy and delete the data. Those are all stealing time from you that you could be using for more useful things. And I think they wear on us as folks responsible for this. So let's remove that burden is what we're suggesting. Let's use software intelligence to take on those responsibilities so we can focus on the bigger picture. And so for that purpose is why we're describing the ability not only to auto-tier within, let's say, disk types, but actually across complete arrays. So part of what the software capability that DataCore brings to the picture is the virtualization of entire SAN arrays. So you can have these very large systems that are already in place and layer the DataCore software on top of that, understanding that it works not only with the existing investments you've made, but as you roll in new technology, you just put that either in a new tier or in place of the tiers and move or decommission the other items out of the way. So this has some additional benefits, which is it increases the application performance because what you're doing is you're not saddling the fastest, most valuable tiers with tying that up with space that it having to reserve capacity for these more mundane things, which tend to aggravate the problem, tend to force, on occasion, more capacity purchases on the tier 1 and tier 2 that you wouldn't have to make if you had vacated those blocks and put them in cheaper storage. So those are all essential kind of takeaways for you as you evaluate your alternatives going forward. The other thing that this does for you is that we have, and we've experienced over the years, and we've been at this for nearly 2 decades now, is that different business owners have different brand preferences. They have different companies and individuals they trust. And so they like to have their own little buckets. And so we can still accommodate that. We can still do that, but treat it all as resources that are available to us in a pinch. So we can have the auto-tiering policy express itself adequately to place the hot data where it belongs and the colder data in its rightful spot. But we can also segregate certain resources, say this project is strictly, this resource is strictly for this project during this period. And so let's cordon that off from some of these decisions. It's also especially valuable when you're going through mergers and acquisitions where you're having to rationalize and in some cases consolidate equipment that wasn't your first choice, but it was certainly the company perhaps that you acquired or that you are now part of that are dissimilar devices, yet they all have, at the end of the day, they were all trying to achieve the same thing. They're all trying to achieve different categories or classes of storage for different classes of data. And you can do that genuinely from the same user interface here. The other way to look at this whole thing is that we know that there's going to be shiny new objects appearing every year. And every time we look at that, if we think about how difficult it is to migrate data to a new storage system, how much time, effort, and planning it takes to migrate data from one to the other and then disposition that resource, it sometimes makes you pause before you make that decision, or maybe you prolong it and delay it because you know how much trouble you're going to go through. So with the idea of having this transparent layer of storage virtualization sitting on top, those can be trivial choices that you make. It's just more a question of funding. So you can inject next generation storage at any tier without downtime. And these folks at Architectural Nexus are a really good example of that. So they look at that and say, I've got an opportunity to purchase latest hardware, and I can put it to immediate use without losing the investment in infrastructure I've bought before, because I simply reclassify that as a slower tier, or I move it to my DR site. Any of those choices are available to you. From an economic standpoint, so we've been talking a lot about operations, but at the outset, this was all about how much are we spending on the data. And so what all these tools are doing is they're helping you match your storage spending to the time value of data. Put it in the right class of storage, most appropriate for its value. The hot data should go on your fastest one, your warm on mid-range, and your lukewarm on secondary data on secondary storage. And then anything that's just really, really cold, the glacial stuff, can be on cheap and deep cloud storage. It's really the only way you can keep costs down, given the propensity to accumulate data. One other thing that this does for you, and put yourself in your buyer's shoes. The fact that the storage devices underneath the layer become interchangeable, because I'm no longer driven by the nuances of that hardware device. I'm actually abstracted from that through the storage virtualization layer. You gain negotiating muscle in your next expansion purchase or your next replacement and refresh. Because if your current supplier is saying, hey, you know, I've kind of can't do as good a deal as I did the last time because circumstances, this and that, and they feel like they have you in a tough spot, you can basically say, look, I can substitute for you at any time I like because it's inconsequential for me operationally. I will shop around for the best deal. I'd like to buy from you. That's the one I've been doing business for years. But if you're making it difficult for me, let me bring somebody else in. For me, it is no big deal to put somebody else in the picture here and reassign your role to a much less important part of our overall infrastructure. So I think it gives you the strength of positioning for the next buy. That's always going to be. Yes, David.
Let me interrupt here quickly with a question. This person is talking about how, you know, they would like to buy a new array, but in many cases they just overbuy because they don't know what data is hot, what's warm, and what's cold, really. Have you seen cases where this solution could help companies? I mean, essentially, would this solution pay for itself when they're replacing arrays or buying new arrays, because it gives them this sort of flexibility that you're talking about?
That's absolutely the case. It's all about, first of all, giving you some empirical information on what that distribution is, first of all. So you're coming from a learned view, not from an estimate. And you can basically say, you can see that when you look at your actual data sets and you look at your working set, which is a working set, is usually where the hot data is, you can see how small a fraction that represents. Where somebody's trying to come in and say, well, wait a minute, you need about 80% of your data needs to be in all flash arrays. You go, hang on, you know, let's look at what's really happening here. And in fact, I only need this little sliver of capacity to be in that. So just that knowledge applies directly to how much you're gonna end up buying. And that's going to save you a boatload of money, and absolutely will pay for itself in making the choice to put data core in there. So really good question. Glad you brought that up. We have a cute little video it's about 2 minutes, and it kind of shows you how we pull this off. And of course, that's one way. If you need to visualize what's going on here, that would be it. And maybe some other your colleagues who want to get the 2-minute version of what we're talking about here, this would be helpful illustration of what the difficulty is and then how we accomplish it easier. Some of the next steps, and I encourage you to take, having understood a bit about what we're doing here is look at the attachment we have. We have a white paper that speaks directly to this, how the choice of hot versus cold and what measures you can take to place that in the right location. And sign up for a live demo. We have our solution architects that can structure an environment that's very representative of what you've got and show you firsthand how that will appear, what dials you have control over, and what insights you can glean from the predictive analytics inside of here to say, oh, that should be my distribution going forward. So with that, I think we'll take any additional questions.
Yeah, absolutely. So we have a lot of questions here coming in from the audience. If you have a question about how this solution works, what storage virtualization is, how exactly you would put it in your data center, now's the time to ask because we do have quite a few questions coming in, and I'll be announcing the winner of that gift card right after our Q&A session here. So let's see. First question, Augie, is this hardware or software? Let's just start with that.
Okay, so it is software. It is I'll use this picture of the software stack. It is software-defined storage in its purest form, and it is one of many data services. So auto-tiering, just to put a spotlight on it, is one of the members that we're showcasing today because all these data services come together. You buy this as a software package that basically sits between the host, the application servers, and the storage. And it is, in some cases, it is delivered through our value-added and authorized resellers as a turnkey system along with hardware. So it can be deployed in several different ways. This will give you an example of some of the ways that it's approached. In some cases, let's say in large data centers where there's a standing number of arrays already, whether they're all-flash arrays, hybrid arrays, and bulk storage pools, we often sit right in between. So these data core nodes, that's basically the software sitting on x86 servers acting as front ends, and it appears to the host like we are just standard SAN arrays. The SAN arrays think we are standard hosts. That's kind of the simple way to look at it. So that's one deployment model or one topology. David, the other possibility is you might have been looking at hyperconverged systems or HCI clusters, in which case data core acts as a software element that's installed right in there. So the aqua blue here that you see in this picture, in this cluster, it might be 3, 4, 16 nodes, whatever. The data core software inserts itself in the IO stream and acts to virtualize whatever internal storage. So if you have flash and HDD drives in those individual servers, then we will make that the composition of the pool out of those resources. And then we also have, for cases where you want to dedicate some secondary storage for this capacity tier, we can do that as well. And they can run both in your main data center. You can also have a complement at your remote office and branch office or at your DR site, and they do not have to look the same. They can be, you can see that the topology here of the main data center is a bit different from what it looks like at the DR site, but the software that's handling things like replication and synchronous mirroring is operating at a higher level. So it doesn't matter what the topology looks like. And you can also run it in the cloud.
Oh, okay, very nice. So a lot of different options for deployment there. This question kind of goes along with that. Noel is asking, can I deploy this on existing storage with volumes and data? Can you clarify that?
Yes, you can. So that's usually how we enter the picture. So typically it is not a greenfield situation. Usually somebody already has data. For example, let's use this picture here. They have data already on existing arrays. Let's say they're big EMC arrays or large HP arrays, 3 pars, et cetera. Those, or even NetApp arrays, something like that may already be in place. So what we'll do is we'll go through a process of remapping the volumes so that they basically are instead of connecting directly from the host directly into the storage array, they're going to connect into us, and we're going to connect into here, and we will act almost like a pass-through is the first way that we enter it. There's a second webinar that we have right on this topic, is how we migrate data and how we enter the picture. So once we're in place, then we can juggle more of the information. So first give you confidence that we're acting well on your behalf, and then the second part is to re-swizzle the organization of the blocks so that we can perform auto-tiering on the overall pool. So we are basically collecting all that capacity across where we see here is like darker gray pool. That's saying this and this have now been ingested, as this would be my tier 1, this would be my tier 2. And I've put that in, and now I can apply the machine learning and the artificial intelligence decisions on that to decide how to best place it.
Okay. So the data core software doesn't run, say, on a SAN. It's going to be a new abstraction layer, a new piece of hardware that's going to come into the data center and perform these services with the existing storage arrays.
Yes,
Is that
yes.
true?
It does not run inside the storage system, but it will if what you have, the other case is you have some, let's say a cluster of regular servers, let's say ESXi servers or something like that. In that case, we're going to be running on those same x86 servers. We'll run, for example, as a virtual machine there, and we will absorb those resources. So never are we running on the storage, but we're always layered on top of the storage and pooling that capacity.
Got it.
Assigning the classification of which tiers correspond to which storage device.
Okay. Okay, and that kind of brings me to the next question here. You mentioned you can run on a virtual machine. Is that a good way to test the solution? And it sounds like it's maybe even a potential option for running it in production. Is that true?
It is, yes, yes. So no, that's a legitimate deployment model for production. It's not exclusively, it's not just for playing around. That is a live, hard hitting. It's actually, in some cases, it is the preferred choice because your applications are that much closer to the data. So they, in some cases, the caching. So if you figure what's going on, if we were to explode this picture, and unfortunately I don't have the overall the blow up of this, but what you would see is that the caching layer is using RAM memory in the server that's close to the virtual machines to respond quickly to the IO request. So that's going to give you a performance boost over not having data core in the picture, where you would have to be hitting the back-end arrays to accomplish that, or the back-end storage to accomplish that, and you would see latency as a result of that.
And that's an interesting point. So the data core software can actually provide a performance boost to the applications. Is that true?
It does, yes.
Very nice.
It's not the theme of today's conversation because we want to first make sure your data is in the right place, and then once you're good with that, then you can start to go, oh, this other stuff's also happening. And what do we attribute that to? Well, we attribute that to a number of other capabilities like parallel I/O, caching, and some of the other attributes that are built into the stack.
Okay. Next question here: how is this solution licensed?
It's licensed by managed capacity, so how many terabytes of capacity you have underneath. So any capacity we see underneath these, let's go back to the other picture. Any capacity we see here, we just license how much capacity that node is capable of holding. Very straightforward. We have 3 editions, 3 models basically. We have one that's kind of the all-inclusive. You get everything in that stack. We have the mid-range offering, which has most of what most people need. And then we have one that's targeted at large secondary storage where performance is not as big a factor. And so we don't accentuate things like caching and some of the parallel I/O capabilities. And those all have corresponding lower price points.
Okay, nice. So a lot of options. I like the option to be, or the licensing method there, where it's licensed by capacity. That makes it easy, especially for smaller companies maybe to get started. Another question here: what about the data core software becoming a single point of either failure or an I/O bottleneck for the data that's passing through it? Could that happen?
Not in best practice. I did show some diagrams that were simple, where we only showed one single instance of the data core software, just to give you an idea of what the flow is. But as you can see here, what the normal configurations is that there's at least 2 instances of data core software acting in an active manner. So the data is in 2 places at any time. And so any I/O that goes to here will also be synchronously mirrored to its companion here. And if this guy or this storage node or this server node or the path to this were to fail, you would still have access to your data through the redundant path, through the redundant node, and to a second copy of the data on another storage device. That's been the mainstream behavior for data core. In fact, data core has made its reputation largely on highly available, performance-oriented workloads, and it's more in the last, I would say, 3 years, where the expansion into the secondary storage and the adjacent capacity tiers has been more pronounced.
Okay, excellent. Another question, they just came in, they're asking, what storage protocols do you support?
Okay, good. Here's that picture. So the storage protocols, there's 2 ways to look at that. On the back end, where we're talking directly as storage, those would be anything that you can expect. NVMe more recently, Fiber Channel, iSCSI, the SAS and SATA protocols, and cloud access. On the front end, that is between the either physical servers, the virtual machines, or the containerized applications, we look like a SAN. We look like either Fiber Channel or iSCSI. We also present up either NFS or SMB/CIFS file shares. The dominant way most people are looking at us is as a block-oriented backend through Fiber Channel or iSCSI, and sometimes they use their own file server heads and connect back in through us through iSCSI or Fiber Channel.
Okay. A lot of flexibility there. And then this diagram here answers another question that came in, and that is, who are the consumers, essentially? So I see there are physical servers, virtual machines, and containers. So this would work, for example, for a vSphere virtual machine? It
would. vSphere, Hyper-V, Xen Server, KVM. It's agnostic to the hypervisor. So we are well-behaved and look like a well-behaved storage device underneath it. The bare metal servers, for example, on bare metal Windows servers, we can also run natively in the kernel in that case. So that for some people that are in the lower end of the range, they are looking at trying to save on the extra cost of virtual machine. So a virtual machine ties up some resources and costs more money to do that. We can run natively in the root partition. But the physical server can also be freestanding, and we sit behind it externally.
All right. Excellent. Let's see. Another question here about data protection. Does this include data protection, for example, backup and recovery, or do you partner with, other third-party companies to do that?
The primary data protection services like synchronous mirroring and advanced site recovery, replication, all of those are built in. Snapshot capability, continuous data protection, that's otherwise known as CDP. Those are built into the software. They're organic elements of the stack. We do partner with outside companies for backup products that have their proxies like Veeam and Commvault and DPM, for example, that are used with host agents that are managing specific backup and recovery and restore at a more granular level.
Okay. So if I wanted replication for disaster recovery for like a critical, tier 1 app that needs synchronous data protection, that is something that you all can provide.
Right out of the box.
Okay, excellent.
Regret box.
Awesome. So what's the best way to get started?
I believe the recommendation that I would give most people is to go through and just set up a live demo with one of our solution architects or one of our authorized partners solution architects, and just express to them what it is you're trying to accomplish and let them orient you in terms of how the scope of what that, the simplicity with which that can be addressed.
Okay, very nice.
And I've given you a link here where you can schedule such a one-on-one.
Okay. And another question just came in here from Dan. Is there any sort of trial licensing that might be available?
There is a 30-day trial. It kind of instantiates itself. It gives you an idea of how to walk through the process. And there's some 2-minute and 6-minute videos that help you at a glance see the entire flow. Those are available right from our website, www.datacore.com.
Excellent. And this is a solution that wasn't just announced last month. This is a solution I actually learned about way back in the 2000s. So you guys have been around a long time. Isn't that right, Augie?
We have. We've been. I don't know if you saw the original picture, but there's a reason that I have gray hair here. It's that I've been here for some number of years, and we are always on the technology cusp, ahead of new technology trends, because a lot of people basically what they're trying to do is be able to modernize quickly, and this is their vehicle to do that non-disruptively. So have over 10,000 installations across the globe. We are in a very international company. So wherever you're listening from, you can reach us.
Awesome. Awesome. Well, it looks like we're running out of time in today's event. Before we go, I want to announce the winner of today's $300 Amazon gift card. That is Carla Cook of Mississippi. Congratulations to Carla. We'll reach out to you to deliver your gift card, or we would love to help you make a donation to charity as well if you're interested in doing that. I also want to thank all the attendees on today's event. Thank you for taking time out of your day to join us. I hope that you learned a lot on this event, and I hope that you found a great solution here to help you solve some of your biggest storage challenges. If you did, I encourage you to visit datacore.com and sign up for the free trial and give it a spin for yourself and see how it might be able to help you. Thank you, Augie, so much for your excellent presentation today.
Thank you, David, so much.
And again, thank you, everyone. Visit datacore.com and also check out the handouts that are available for download there in the audience console. I hope that everyone learned a lot, and have a great day. We'll see you on the next event.